So we're going to talk today about autonomous in the cloud. Two subjects that are very close to my heart. But we're going to start the conversation discussing a little bit about this point of what is AI, other than the most hyped topic in our industry at this moment. What is AI? So there are many definitions. One definition is artificial intelligence. AI stands for artificial intelligence. Machines delivering human-like intelligence. To deliver human-like intelligence, you must have the capability to learn. To me, that's the fundamental essence of human intelligence, is learning. So we'll talk about that as a critical capability. If you're going to be autonomous, if you're going to be intelligent, you better be able to learn. There's another definition of AI, which is automated intelligence. This more or less says, we'll do what the humans do, we're just automating. We're not actually doing it any better, we're just making it faster and cheaper. This to me is less interesting. Because if we're not learning, if we're not getting better, then kind of what's the point? There's another definition, which is probably my favorite one, which is augmented intelligence. No matter how smart your AI software is, humans, we still have the edge. We're still smarter in many domains, not all domains, but in many domains than the software. So augmented intelligence says that we're going to allow the software and the humans to work together. And when that happens, we get even better outcomes. Bottom line is, AI is whatever you want it to be. So we're going to make AI what you want it to be. We're going to deliver AI inside Vantage. Now you know we're already delivering machine learning capability on the outside of Vantage, and many of you are already using that to do very cool things. But we want to also lift the covers this morning and tell you a little bit about what we're doing on the inside to help make your Vantage life better. So let's start with a very basic capability that many DBAs, database administrators, have historically spent a lot of time on. Manual effort to figure out where should I collect the statistics that describe the demographics of the data inside my analytic ecosystem, essentially creating the knowledge so that the optimizer can make smart decisions. And the problem with statistics is that it takes actually a lot of effort to figure out where are the places that I need to collect statistics versus, I invest in collecting statistics, but it actually didn't help us get any smarter. So where and when to collect statistics is something that DBAs used to think about a lot. With the machine learning inside the autonomous capabilities of Vantage, we're able to dynamically and continuously optimize where and when to collect statistics. You don't want us collecting statistics right when your mission critical, high performance service level query is running. No, you want us to do it when it doesn't matter so much. When we've got those free cycles, or in the cloud when you've got spot pricing. I want to collect statistics and use resources when it's really cheap to do that, not when it's really expensive to do that. I want DBAs not to have to figure this out. It should all be done automatically under the covers. You don't even know that statistics exist because we're doing it underneath the covers. Right? So when we talk about autonomous in the database, these are the kinds of things that we are developing, working on inside the labs at Teradata to make AI what you need it to be, what you want it to be. Another example is compression. We want to squeeze the data as hard as we can so it takes less space on those disk drives in memory. But when we squeeze, that actually takes computation. We have very complex compression algorithms invoking complex mathematical formulas, And by the way, we don't just have one compression algorithm, we have lots of compression algorithms, and depending on the nature of the data that you have, we would choose different mathematics for different types of data, for different demographics of the data. And so with the compression, in the old world, again, a very smart DBA or systems architect would have to figure out which compression algorithm should I use on this data versus that data. And by the way, the data is changing all the time. And so the answer changes all the time. So this isn't a one-shot deal. This is something that you'd have to revisit periodically. Well, in compression data AI, essentially, the machine learning's job is to continue to learn from the data, learn which compression works best. Also, depends on your access patterns. Data that's not accessed as frequently, we may want to squeeze harder because you don't access it frequently. I want a very low cost per terabyte by squeezing those bytes down really hard. And I'd be willing to pay a little bit more in CPU costs to decompress in order to save the space, save the money. Because, by the way, if you're not accessing it very often, you're not going to invoke those CPU cycles very often, but the data's already there. So let's squeeze as hard as we can. Automatically. You shouldn't have to think about these things. In the world of autonomous vantage, we don't think about these things. The software does the work for you. The intelligent software. Intelligent, again, means learning. So it's not a one-shot deal. We learn, and we may choose a different compression algorithm today than we do tomorrow because the demographics of the data is changing, the access patterns are changing. These are capabilities that, again, our R&D teams are working on to deliver to you for the AI that you want, the AI that you need. Indexing. We never have enough indexes except when we have too many. And what happens is people run some query, oh, the performance is not what I want it to be, let's build an index. And then some weeks later, some months later, some years later, people build it, they never ever get rid of indexes. And they just accumulate more and more of these things. And those indexes, they require work to be done every time you insert a new record into your Vantage analytic ecosystem. They require space to store those index structures. Having the wrong indexes, having too many indexes, or having not enough indexes, these are all bad things. With machine learning, we can continuously learn and evaluate which are the indexes that we should have. And maybe an index was a really good idea a year ago, but we're going to notice by the access patterns, but actually that index is no longer very useful. Let's get rid of it. Completely automatically. Learning from your access patterns, and we have the access patterns, we have everything. The query logs, we keep track of all the workload going on in your system, and we know exactly what's going on, and we can learn from that. And we do learn from that in our software to make your life better if you're a DBA, certainly, but also if you are a knowledge worker accessing that data, we want it as fast as possible. And we don't want to have to go to a DBA. Please, my query is not running as fast as I want. Can you please build an index for me? Actually, you wouldn't even know their indexes anymore. They don't exist as far as you're concerned. They don't exist. But underneath the covers, actually they do exist. But if you don't have to worry about them, they don't exist. From a DBA perspective, from a knowledge worker perspective, they don't exist. Except by performance of those queries benefits from having those structures built. And when technologies say, we don't have any indexes, that's so much easier to manage. Yes, not having indexes make it easy to manage, but it also makes you wait a very long time for a query that would have benefited from that index. So we want them, but we don't have to worry about them. That's the idea in autonomous Vantage capability that our R&D labs are working on for you, delivering to you. ETL.ai. extract, transform, load. We extract the data from the source systems, and it's messy. And we spend a lot of time figuring out how to map that data from the source systems into our integrated data model that makes that data usable and even reusable. Extract, transform, load. Most organizations, when they're building an analytic ecosystem, probably spend about 70% of the human effort. And that translates to time to delivery. It translates to the money that I spend in creating my analytic capability on the mapping of the data from source to target. It's a very manual effort in the old world. In the new world, we learn from the data. We analyze the data. We understand the patterns in the data, and we can recognize, hey, this looks a lot like a gender context for that data. This is clearly the balance for the account, and we can start to recognize these things even when you have source systems that give crazy names like P100356. I've seen source systems with those names. And by the way, they're limited to only 8 characters in some cases, right? Ugly, ugly stuff. The machine learning learns not just from the names in the metadata, but actually the content of the data. So machine learning will automate the mapping and schema discovery from source to target. And with that information, you can then operationalize much more effectively with whatever your favorite ETL tools are and so on. Right? But we want to eliminate that human part. And I mentioned earlier this concept of augmented intelligence. This turns out to be very, very complex. And we've done this work with data coming from a number of standard source systems. And we know that actually having a human sort of do a tweak here and there will probably make sense for most of you. So it's not what I would say completely automated, it's augmented intelligence. But if we could take that 70% of work down to single digit number, that's huge. Absolutely huge. ETL.ai automates and delivers learning from the data to take this 70% cost and time to delivery thing to something much, much smaller. So you're going to see us talking about this capability together with some of our partners in the industry to make this a reality in how you build your Vantage ecosystem. Optimizer.ai. You say, how can you possibly make the best optimizer in the industry better? The workloads that we are executing in Vantage have evolved significantly over the last several years. Teradata's cost-based optimizer with the most sophisticated algorithms, with the most sophisticated capabilities, not just from the optimizer itself, but what we're able to do with the file system and how we organize the data, are part of the secret sauce that allows Teradata to deliver the performance, deliver the scalability that all of you in this audience enjoy, or if you're a prospect, maybe are soon to enjoy. But it's not just about SQL anymore. SQL is not good enough by itself to deliver the advanced predictive and prescriptive analytics. So we have to introduce additional capabilities, execution of non-SQL kinds of things within the Vantage infrastructure. So that analytics platform has the ability to do machine learning kinds of things and advanced SQL kinds of things that are not part of the typical model that you would have in a cost-based optimizer. So what we've done, and actually most of you already have it if you have a recent version of the Vantage software. You just don't know it. And by the way, that is the best kind of feature. The kind of feature that I don't have to do any work to get the value. Perfect. Because if I have to go and tweak a knob or change a dial or type some commands to configure something, that's work and that's friction. When we're introducing the capabilities to optimize the advanced SQL capability in Vantage, we want it to be completely invisible. And we will learn, we will keep track of, actually, I've seen queries that look like this in the past. And I know that if I make this kind of execution decision, that I'm going to use a different level of resources than if I use that kind of execution decision. So we're learning with the software, learning from the data that we collect. The telemetry from your Vantage system gets collected, and we use it to get smarter in how we optimize. And it's not just about SQL optimization anymore. It's about optimization of the advanced SQL, the machine learning capability that Vantage delivers to each and every one of you. So this is absolutely huge. Service level goals. Teradata is well known for having the best workload management in the industry. Not even close. But best is not good enough. We have to continuously better our best in order to deliver the capability that you need to continue to be successful as your workloads become more complex, as the concurrency of queries increases, as you're combining strategic intelligence and operational intelligence and reusing that data with very different service levels. So with our workload management, TASM, Teradata Active Systems Management capability that you have, you've got lots of ways to sort of optimize the resources that you have. And in the past, this was focused a lot on an environment which was on premises, where resources were scarce. You had to fit all your workload in whatever size box was in your data center. The cloud is a very different world. The cloud is a world where we're not optimizing for scarcity of resources, we are optimizing for abundance of resources. And so with SLG.ai, we changed the paradigm a little bit. We're still leveraging all that advanced workload management capability that we have within Vantage. But now, what we want you to do is specify this is the service level goal for this piece of workload. Now again, we're not going to specify it on a query by query basis, of course, but you have rules that say when I get a query from the application that is to deliver customer information to my call center rep with a recommendation of what product I should be helping them acquire, I want that service level to be less than 200 milliseconds. When I have a drill down in the financial application where we're looking at how to optimize pricing and so on, well, maybe that service level can be 3 seconds. And maybe we're doing a profitability analytics on 50 million customers, and I don't really care when that finishes as long as it does finish. And so we have different kinds of service level goals for different workloads. So rules based on who is the user submitting the query, rules based on the application submitting the query, rules based on what is the cost of the query and what should therefore be the expectations of the user of how fast something's going to come back to me. So we can specify service level goals, which are probably based on the service level agreements that you have made with your knowledge worker community, and then we will allocate the resources necessary to meet that service level goal. Now what's interesting about this is that if you execute much faster than the stated service level goal, actually you don't really get extra credit for that. Because consistency in response time is actually more important than having something much less. So if the service levels bounce around a lot, people get uncomfortable. The service level goal is set for a reason because it aligns to the business process that I'm trying to support. But if you miss the service level goal, big penalty for that. So the optimization is all about how do we make sure to meet the service level goal for each and every piece of the workload you have. And because of the elasticity in the cloud, we can accumulate more resources to make that reality, but not overspend on queries where it doesn't add value to get it done faster. So what you know as the workload management foundation in Teradata today, we're working on projects within the R&D labs to take it a huge step forward as part of our cloud first initiative and getting the capabilities of the service level goal allocation of resources aligned to your business process requirements. TVS, Teradata Virtual Storage. Again, I'm not in marketing. This may not be the name that you get in the end, right? Don't ever let engineers name your products, right? You get stuff like TVS. Teradata Virtual Storage.ai. What does that mean? Well, as Martin mentioned yesterday, we have decoupled the compute and the storage advantage. And within the storage, in the old world, it was very homogeneous. You had one storage type and you had lots of it. But in the new world, we have many storage types. We have storage types. We have memory. We have solid state disk drive. We have spinning disk drives. We have native object store now. You heard that yesterday. So where to put your data? Where should your data go? Whose problem is that? It needs to be our problem. It needs to be the problem of the software. We don't want DBAs to be worrying about this stuff. Right? And by the way, TVS is not some brand new capability. We've had TVS under the covers for quite some time. Teradata Intelligent Memory, many of you will know, we have used machine learning inside Vantage for many years to figure out what is the data block likely to be optimized in memory or on solid state disk drive or an electromechanical drive. We've had this capability for a long time. And we predict based on the workloads which data we need to have in memory and which data is not going to be in memory. And based on your workload patterns, we will sort of promote data from low performance cheap storage to higher performance low price per I/O is different than low price per terabyte. And so TVS does that already today. Now as we introduce native object store, our first MVP is that native object store so that you choose which data goes into the native object store and which data will go into the Teradata file system. But it would not be a huge intellectual leap to understand that these TVS capabilities that we've had in Teradata for a very long time could be extended into the native object store. This is not a product announcement yet, but you can clearly see the direction of extending Vantage capability that we already have using machine learning for optimizing what data goes in memory and SSD and storage to additional storage type like native object store. So we will continue to expand the capability of TVS. Now, I mentioned earlier augmented intelligence. You know, in some cases, a really smart DBA is going to outperform a really smart piece of software. And so it's important that, especially for those workloads that you really tuned or those tables that you paid a lot of attention to and figured out the optimal statistics and indexing and so on, that if the DBA wants to keep control, we allow that to happen. So you can decide whether you want our machine learning software to manage at a database level. You can create profiles for which the autonomous Vantage will apply, but other profiles for which you want sort of manual capability to manage. User-based, table-based, so there's a lot of flexibility in what is the mix of the automated intelligence, artificial intelligence, versus what's the augmented intelligence where you really want the human expert to be involved. So I don't want people to get afraid of this discussion of AI, that you're losing control. You're losing control where it makes sense, where you want to lose control. I actually don't want to, in my vehicle, to go in there and tweak underneath the hood, the fuel injector and so on. I just want it to run really fast, and I don't want to think about it. That's what this autonomous Vantage capability is for. But in some